Okay, let's talk more stoichiometry. This time we're going to get into something called a limiting reactant. And previously, when we've looked at stuff, we've kind of just assumed that the only thing we're looking at is the one that's important. I don't know if that makes any sense whatsoever. Um, we are assuming we have infinite amounts of the other stuff, if that makes any sense. Um, in reality, that's not always the case. That's hardly ever the case, right? Um, you have some amount of different reactants that you're mixing together to do the reaction. Okay, and so we're going to look and see how that works. Okay, this is when we have a limiting reactant kind of situation. Okay, um, the limiting reactant is very important because it is the one that decides how much product is actually made. Okay, so the amount of product is determined by how much limiting reactant we've started with. When the reaction, when the limiting reaction is all used up, the reaction is done and it stops. Nothing else happens after that. Okay, anything that's any reactants that are left over when the reaction stops, we say are in excess. Okay, you'll see this word in excess a lot in, maybe not a lot, but you'll see it in questions sometimes. Maybe you'll say crap. Maybe you'll see a question that says, um, I don't know, you have 5.6 grams of water plus excess HCl. All this means is this is no longer a limiting reaction problem. We're going to start with this amount that we have here, and we have excess, which just means we have enough, we have plenty, we have more than enough, we have tons, we have a lot of HCl left over. Okay. All right. This is something you kind of already do, but you don't ever think of it in life about this as a chemistry problem. Okay. Let's say we want to make sandwiches. Okay. And your sandwiches are going to be two pieces of bread, two pieces of cheese, and three pieces of meat. This is going to make one sandwich. We can think of this as our equation, but we're just going to kind of think through it as sandwiches. Okay. Bread, cheese, and meat. We're going to make a sandwich. All right. If you have 6 bread, 8 cheese, and 10 meat, how many complete sandwiches can you make? And I bet it won't take you very long to figure out that you can make 3 sandwiches. Okay. How did we figure that out? Well, let's see. 6 bread. 6 bread. If we have 6 bread, we can make 3 sandwiches. Okay. If we have 8 cheese, we can make 4 sandwiches. And if we have 10 meats, uh, then we can make 3 1/3 sandwich. Okay. What we've seen here is the most complete sandwiches that have all the bread, all the cheese, and all the meat that we can get is 3. Okay. Right. We don't have enough bread to make 4 sandwiches. Okay. So this tells us two things. We can make 3 sandwiches that are complete. This tells us that bread is limiting. Okay. It also tells us that meat and cheese are in excess, right? They are left over. Oh shit, left over. Okay. Other things that we can figure out, um, we can figure out how much cheese is left over, right? If we make 3 sandwiches, that means we've used 6 pieces of cheese. So there should be 2 cheese left. Okay. This is literally a stoichiometry problem. We're just using it with delicious things instead of chemistry, but it works the same way. Okay. Keep in mind, we're not thinking about slices of bread, meat, or cheese. What we're thinking about is where'd my, there it goes, moles. Okay. So let's take a stab at a more chemistry flavored example. Okay, let's make some water. And we're going to say, I'm going to leave grams out of it for this, just so we can look at how this works without the grams there. All right, how many moles of water are formed? Remember, we're going to have to figure out how much we can get from every one of our starting material points. Okay, so we're going to figure out hydrogen and figure out how much water we get. And we're going to have oxygen and we're going to figure out how much water we're going to get. And then we're going to compare. Okay, so we're starting with 1 mole of hydrogen. Our equation tells us if we have 2 moles of hydrogen, we're going to get 2 moles of water. Okay, so from the hydrogen, this tells us we're going to be able to make 1 mole of water. Okay, now if we have 1 mole of oxygen, right, that's what we've mixed together, 1 to 1, 1 mole of oxygen and 1 mole of hydrogen. 1 mole of oxygen, our equation tells us 1 mole of oxygen will make 2 moles of water. Does that make sense? Okay. So this means we're going to get 2 moles of water. Okay. So we have to actually answer the question now. How many moles of water are formed? 1 mole of water can be formed. So this is our answer. You don't have to write answer, but this is the max amount of water possible. Okay. We're going to have O2 left over. Okay. If we wanted to, we could figure out how much O2 is left over, and I'll show you how to do that later. This also tells us that hydrogen is limiting, right? That's our limiting reactant, okay? Because the hydrogen was used up, that's the limiting reactant, okay? Our answer is the lesser, the smaller of the two things that we figured out, okay? All right, let's take a stab at one that has grams in it, okay? Yeah, all right. So we have 7.36 grams of zinc and we have 6.45 grams of sulfur, and we want to know how many grams of zinc sulfide are produced. Okay. We didn't throw the words limiting reactant in there, but we have starting amounts of two different things. This is a sign that we have a limiting reactant problem. So we're going to do this the same way. We're just going to have to do it with grams now too. So we're going to take grams of something, convert it to moles of that thing, convert that to moles of zinc sulfide, and then convert that to grams of zinc sulfide um, to figure out grams of zinc sulfide. Always take both reactants to the same product and compare grams. Okay, you might as well figure out grams because we're looking for grams for the answer, and that's going to save our butts. Okay, so here we go. I'm going to set them up both and then we'll just solve them. All right, 7.36 grams of zinc. Ooh, excuse me. 1 mole of zinc. We can look on the periodic table and grab that molar mass. 65.41 grams of zinc. Okay. Our equation here tells us 8 moles of zinc will give us 8 moles of zinc sulfide. And we'll get the molar mass of zinc sulfide because I gave it to us up here. 1 mole of zinc sulfide is 97.48 grams of zinc sulfide. Remember, formulas and units on everything. Okay. We've got zinc sulfide. Let's go through and calculate it for starting with sulfur. So 6.45 grams of sulfur, which is S8 in this case. 1 mole of S8 molecules is 256.56 grams. I gave it to us up here. Don't calculate it. Save yourself the time. 256.56 grams of sulfur. All right. Our equation tells us 1 mole of sulfur will give us 8 moles of zinc sulfide. Okay. And molar mass of zinc sulfide again. Our end step should be the same for both calculations because we're solving for the same thing, and that is grams of zinc sulfide. Okay. If we start with sulfur and figure out grams of zinc sulfide, we end up with 19.6 grams of zinc sulfide. And if we start with zinc and calculate zinc sulfide, we end up with 11.0 grams of zinc sulfide. Yes, you need to figure out both grams. Yes, both of these answers need to have the correct number of significant figures. Um, Now we just have to answer the question. If you stop here, you are not completely correct. We have to make the point and say, yes, we know what the answer is. How many grams of zinc sulfide are produced? 11.0 grams of zinc sulfide are produced. Okay, make sure we know that that's our answer. We can make a comment here and say, because this is the max amount possible, make a note here, this is the max amount possible, then zinc is limiting. Okay, that's what we mean by limiting reaction. When the zinc is used up, the reaction is going to stop. Okay, oh, that was it. All right, practice, practice, practice. Show your units, show your formulas. Don't spend a lot of time calculating molar masses. You don't have to. Let me know if you have problems, um, and I'll catch up with you later.